Welcome back, everyone. This is chapter 14 on acids and bases, and we're at a very short section, the shortest section of the chapter, in section 9, which is acid-bases properties of salt solutions. If you were to have a glass of water and put some various salts in that water, and then take the pH of that water, sometimes you would have acidic solutions, sometimes you would have neutral solutions, and sometimes you would have basic solutions. I'm going to try to help you to predict, based upon what you know of strong acids and strong bases, whether you're going to get an acidic, basic, or neutral solution from the salts that you put in. So some of this is memory, but some of it also is just figuring it out, knowing what you know about strong acids and strong bases. So let's look at some examples. If you were to have a salt that contained the ions of a strong acid and the ions of a strong base, then what would happen is you would form a neutral solution. So let me give you an example. If you were to have potassium nitrate, if you remember, potassium hydroxide is a strong base. It's on the list of strong bases. And nitric acid, which is HNO3, is a strong acid. So if you have potassium nitrate as a salt and you put it in water, what will happen is it dissociates, breaks apart. Remember that potassium is very soluble. It's in the pool, and they break apart into cations, K plus 1, and the NO3 negative 1. Well, what can happen is from the water, it can form a strong acid and a strong base. Well, the strong acid, which is HNO3, will neutralize with the strong base of KOH and neutralize into a pH of 7. So if you have a strong acid, it completely dissociates, and so all the ions are in the water, and you have a strong base in the water, it'll neutralize. That's what a neutralization is. If you have a strong acid and a strong base, it goes to a pH of 7. The H's and the OH's recombine to form water. Water is a neutral at 7. Okay, so here's the first one that you're going to have to kind of put your mind around, memorize if you need to. And that is that if you have the salts that is made up of a strong, so the beginning, remember, is going to be the base. The cation is going to be the cation from a strong base. The anion is going to be the anion of a strong acid. So the strong acid, remember, is HNO3 and then KOH. So when you put those together, the water supplies the rest. The water supplies the supplies the proton and the hydroxide, and you're going to end up with a neutralization reaction. So you're going to have a neutral solution when you have strong acid, strong base, anions and cations. If you have a weak acid and a strong base, okay, then what's going to happen is that the strong base will completely dissociate. The weak acid, when it comes back together, will form mostly molecules. And what you have, whatever is strong is going to show up. You've got the strong base, and so it's going to be acidic, or a basic solution, sorry. It'll end up being very basic, an alkaline pH, a high pH, 12, 13, 14. Okay, here's an example. KHCO3, okay? HCO3, remember, if you were to have a weak acid, acetate is a weak acid, acetic acid, that's vinegar, is a weak acid. So if you were to have H2CO3, acetic acid, that's mostly going to be molecules. You're only going to have a little bit, and you'll end up with, all that acid is not being broken apart. It's not dissociating. So the acid level in the water is not going to be high. But the potassium is the cation for a strong base. KOH is a strong base. So when it completely dissociates, you're going to end up with a basic solution. So if you have a weak acid which doesn't break apart completely, it's not going to be able to neutralize the base that does break apart completely. So you're looking at the one that is the is the strong. The strong will always show up. The weak doesn't because it doesn't break apart. So if you have what will turn into a weak acid, it stays as molecules and doesn't dissociate and doesn't make the water solution acidic. So in this case, if you have the ions of a strong base and a weak acid, the base shows up and your solution will be basic or alkaline. What if you have the reverse? What if you have the cations or the ions of a strong acid and a weak base? The weak base doesn't completely dissociate. It stays mostly as molecules. The strong acid completely breaks apart, and you end up with acidic solution. So your example here is ammonium chloride. Okay, if you remember, ammonium is part of ammonia, and that's a weak base. It doesn't break apart very much. It stays mostly as ammonia, and so the strong acid then will show up. HCl, chlorine is from HCl, that's a strong acid. It completely dissociates, and you end up with an acidic solution. So to review, if you have a strong acid and a strong base coming together, these are the parts that make strong acids and strong bases. Remember chlorate and hydrobromate, hydroiodide, and nitric acid and perchloric acid. These are from the ones you memorized. These are the ones that make strong acids. So if you have the cations that are part of the strong base and the anions from a strong acid, you'll get a neutral reaction. You'll neutralize and you'll have a pH of 7 or close to 7. If you have strong bases but weak acids, the strong bases will dissociate and you'll end up with a high pH. So if you have the cations from strong bases but the anions from weak acids, the weak acids stay mostly as molecules, the ions dissociate in the bases, and you end up with a higher than 7 pH. And if you have weak bases but strong acids, the acids completely dissociate and you'll have a less than 7 pH. So you'll have an acidic solution. So that's it. That's a very short lesson. So a cation from a strong base with an anion from a strong acid, you get a neutralization. Cation from a strong base, anion from a weak acid, it's greater than 7. It's going to be basic. And if you have a cation from a weak base and an anion from a strong acid, it'll be less than 7. It'll be acidic. So you're looking for whatever's strong. Whatever is strong. And again, that's from your memory of which is strong and which is weak. Luckily, that's a very short list that you have to memorize. Okay, that's all. I'll see you in class.